Today, we're going to follow your food on its absolutely incredible 9-meter journey through your body. It's a path we all use, multiple times a day, but one we almost never really think about.
I mean, it's a simple question, isn't it? But the answer? Oh, it's this complex and pretty fascinating biological masterpiece. We're going to break it all down, step by step, using what our source material calls a 100% accurate guide to your digestive system. Okay, let's dive right in.
So first things first, what is digestion really? Before we can even start this 9-meter trek, we kinda have to understand the main mission, turning that sandwich or salad into the actual fuel that keeps you going. At its absolute core, digestion is the body's brilliant way of deconstructing food into tiny, usable parts. It's a process of taking complex things and making them simple. That's called catabolism, so that our bodies can then use those simple building blocks to build us back up.
So how does the body do it? Well, it tackles this mission with a two-pronged attack. First up, you've got mechanical digestion. That's the literal crushing and grinding, chewing. And then comes chemical digestion, which uses these specialized proteins called enzymes to dismantle food on a molecular level. It's really a 1-2 punch of brute force and chemical precision.
So, this journey we've been talking about, just how long is it? Well, it's about 9 meters. That's nearly 30 feet. That's the total length of the alimentary canal, this long, winding tube your food travels from start to finish. To put that in perspective, that's roughly the height of a 3-story building.
And that entire 9-meter journey, the height of a whole building, it all starts right here. The second that food passes your lips, the whole digestive process is already kicking off.
Think about this for a second. Your body produces up to 1.5 liters of saliva every single day. That is more than a large bottle of soda. And this isn't just water. It's this incredibly sophisticated cocktail designed to kickstart the whole process.
Saliva is basically a triple threat. First, an enzyme called amylase starts chemically breaking down starches. Then you've got lysozyme, which is kind of like a bouncer, killing off harmful bacteria. And finally, mucus lubricates everything, bundling it all up into this neat little package called a bolus, getting it ready for the next stage.
So next, that bolus gets passed down to the esophagus. Now this isn't just some simple tube, it's a muscular contractor. Through this really cool wave-like motion called peristalsis, it actively squeezes and pushes the food down towards the next major destination. And this next stop is a wild one. Welcome to the stomach, a muscular, churning bag of acid and incredibly powerful enzymes. This is where digestion really gets serious.
The stomach is a multitasking marvel, really. Hydrochloric acid just annihilates bacteria, while enzymes like pepsin and renin get to work dismantling proteins. But here's the absolute genius part. A layer of mucin protects the stomach wall so it doesn't get dissolved by its own powerful acid. Amazing, right?
Okay, so after the stomach has worked its magic, the food, which is now this semi-liquid paste, moves into the small intestine. But it doesn't go in alone. Oh no! It's about to meet the specialist chemical crew from the liver and the pancreas.
Your liver is basically a chemical factory, and one of its star products is bile. It makes up to 1 liter of it every day. And bile's job is super important. It takes these big blobs of fat and emulsifies them. It breaks them up into teeny tiny droplets. This gives the fat-digesting enzymes a much bigger surface area to attack, making them way more effective. Now, if the liver provides the prep work for fats, the pancreas brings in the demolition crew for just about everything else. Its secretions are so effective that our source material actually calls them the complete digestive juice.
And here's why it's so complete. The pancreas releases its own all-star lineup of enzymes, amylase for any leftover starches, trypsin for proteins, and lipase to finish the job on those fats that the bile just prepped. It really does cover all the bases.
All right, with all the chemical tools now mixed in, our food enters the longest, and you could argue, the most important part of its journey. This is where the body finally gets to reap the rewards of all that hard work, the final stage of absorption.
And if you thought 9 meters for the whole system was long, get this. The small intestine alone can be up to 7 meters long. That's over 22 feet. So why so long? Well, it's all about maximizing the time and the surface area for absorbing all those valuable nutrients we've just worked so hard to unlock.
Now, this 7-meter tube is split into 3 special sections. First is the duodenum. That's the mixing bowl where the acidic food paste from the stomach meets up with those juices from the liver and pancreas. Then comes the jejunum, which is the main absorption zone. And finally, the ileum squeezes out every last bit of nutritional value. So how does the small intestine absorb everything so efficiently? Well, the secret is these things called villi. The inner lining is covered in millions of these tiny finger-like projections. They increase the surface area enormously, creating this massive contact zone for nutrients to pass right into the bloodstream. It's an incredible design.
So what happens to whatever's left over? Well, that moves into the large intestine. Its main job isn't really nutrient absorption anymore, but water reclamation. It soaks up most of the leftover water and salts from all the indigestible stuff, compacting it into semi-solid waste. And tucked away right where the small and large intestines meet, there's this little finger-like tube, the appendix. Our source material is pretty clear on this one. In humans, it's considered a vestigial organ. It's a relic from a time when our ancestors' diets needed it to help digest tough plants. But now, it's redundant. And that kind of brings us to a final thought. We've just journeyed through this system that is, for all intents and purposes, 100% accurate and efficient for what we need right now. But the very existence of the appendix proves that this system evolves. So it makes you wonder, doesn't it? As our diets and our lifestyles keep changing, what part of this incredible journey might become the next appendix?